Microservices are a way of designing software. They break down a large application into smaller, independent services. Imagine a car. It is a complex machine, but it is made up of many smaller parts. Each part has a specific job. These parts work together. This makes the car run. Microservices are like these parts. They each have a specific function. They communicate with each other. This allows the larger application to work. Microservices are independent. This means they can be developed and deployed separately. This makes them very flexible. Teams can work on different microservices at the same time. This speeds up development. It also makes it easier to update and scale the application. If one microservice fails, the others can continue to function. This makes the application more resilient. Microservices use lightweight communication protocols. This means they can talk to each other easily. They are also technology agnostic. This means they can be built using different programming languages and frameworks. This gives developers more flexibility. They can choose the best tools for each microservice. Overall, microservices offer a more agile and scalable approach to software development. They are becoming increasingly popular. This is because they help companies build more robust and adaptable applications. Microservices are becoming essential in the realm of software development. This is because of the increasing complexity and demands of modern software systems. Applications today are expected to be highly scalable, resilient, and adaptable to changing needs. Traditional monolithic architectures often struggle to meet these evolving demands. This is where microservices come into play, offering a more flexible approach. Monolithic applications can be compared to a single large machine. All the parts within this machine are interconnected and interdependent. This interconnectedness makes them difficult to change or update without significant effort. Any modification in one part of the system can affect the entire application. This often leads to long and cumbersome development cycles. It also increases the risk of errors. Microservices offer a robust solution to these issues. By breaking down the application into smaller, independent services, microservices provide greater flexibility and control. Each service can be developed, deployed, and scaled independently, without affecting the others. This independence allows for faster development cycles and more agile responses to changes. It also significantly reduces the impact of changes, as updates can be isolated to specific services. If one service needs to be updated, it can be done seamlessly without disrupting the entire system. This modularity is crucial in today's fast-paced digital landscape, where rapid adaptation is key. Businesses need to be able to adapt quickly to changing market conditions and customer needs. Microservices provide the agility and flexibility required to do so effectively. They allow companies to deliver new features and updates more rapidly and efficiently. This gives businesses a competitive edge in the market. Moreover, microservices align well with modern development practices and methodologies. They support continuous integration and continuous delivery, commonly known as CI/CD. This means that code changes can be deployed to production quickly and frequently, enhancing productivity. This accelerates the feedback loop, allowing for quicker responses to user feedback and issues. It allows companies to iterate and improve their applications more rapidly, ensuring they stay ahead of the competition. Microservices are a software architecture style. They structure an application as a collection of loosely coupled services. These services are small and focused. Each microservice is designed to perform a specific business capability, independently deployable. Microservices can be deployed and updated independently of each other, technology agnostic. Microservices can be built using different programming languages, databases, and technologies, organized around business capabilities. Microservices are typically aligned with specific business functions or domains, owned by small, autonomous teams. Each microservice is usually managed by a dedicated team that is responsible for its development, deployment, and maintenance. These characteristics enable the benefits of microservices. The small size and independent nature of microservices make them easier to develop, test, and deploy. This allows for faster development cycles and more frequent releases. The technology agnosticism allows teams to choose the best tools for the job. The organization around business capabilities promotes a clear separation of concerns. This makes the architecture easier to understand and maintain. The ownership by small, autonomous teams fosters agility and accountability. Teams can work independently and make decisions quickly. In essence, microservices offer a more modular, flexible, and scalable approach to software development. They are well suited for building complex applications. They can adapt to changing business requirements. Section 4. Microservices versus monolithic architecture, a comparison. Microservices and monolithic architecture represent two fundamentally different approaches to building software applications, each with its own set of advantages and challenges. Understanding their differences is crucial for choosing the right architecture for your specific needs and goals. A monolithic application is built as a single, unified unit, where all functionalities are tightly integrated. All components are interconnected and interdependent, meaning they share the same code base and resources. This interconnectedness makes it difficult to change or update individual parts without affecting the entire system, leading to potential downtime and increased risk of errors. Monolithic architectures are generally easier to understand and implement, especially for smaller applications due to their straightforward design. In some cases, monolithic applications can be faster than microservices as there is no overhead from inter-service communication, which can introduce latency. Testing a monolithic application can be simpler, as all components are contained within a single unit, making it easier to identify and fix issues. However, making changes to a monolithic application can be time-consuming and risky, as any modification can impact the entire system, requiring extensive testing and validation. Scaling a monolithic application can be challenging, as it often requires scaling the entire application, even if only specific components are under heavy load, leading to inefficient resource use. Monolithic applications typically use a single technology stack, which can limit flexibility and innovation, as teams are constrained to the tools and languages chosen at the start of the project. In contrast to monolithic architecture, a microservices-based application is composed of small, independent services, each responsible for a specific functionality. These services communicate with each other over a network, often using lightweight protocols like HTTP or messaging queues. Microservices allow for greater flexibility, as individual services can be updated or replaced without affecting the entire application, enabling continuous delivery and deployment. Microservices can be scaled independently, allowing for more efficient use of resources and better performance under heavy load, as only the necessary services are scaled. Microservices can be built using different programming languages, databases, and technologies, allowing teams to choose the best tools for the job, fostering innovation and adaptability. However, microservices introduce complexity in terms of inter-service communication, data consistency, and overall system management, requiring robust monitoring and orchestration tools. Testing a microservices-based application can be more challenging, as it involves testing the interactions between multiple services, each with its own dependencies and potential points of failure. Deploying and managing a microservices-based application can be more complex than deploying a monolithic application, as it requires handling multiple deployments, versioning, and service discovery. The choice between a monolithic and microservices architecture depends on the specific needs of the application, including factors like team size, project complexity, and long-term maintenance considerations. Monolithic architectures are often suitable for smaller, simpler applications that do not require frequent updates or high scalability. Microservices are a better fit for complex, evolving applications that require high scalability, flexibility, and technology diversity, making them ideal for large-scale, distributed systems. Section 5. Components of a microservice architecture. A microservice architecture is more than just breaking down an application into smaller services. It is a comprehensive approach to designing and managing software systems. It involves a set of interconnected components that work together to ensure the smooth operation of the system, providing flexibility and scalability. At the heart of a microservice architecture are the individual services themselves, each designed to handle a specific function. Each service represents a specific business capability and operates independently, allowing for more focused development and deployment. Microservices communicate with each other through APIs or application programming interfaces, which act as the glue holding the architecture together. These APIs define the methods and data formats for inter-service communication, ensuring that data is exchanged seamlessly and correctly. In a microservice environment, services may be dynamically allocated to different servers or containers, optimizing resource usage. Service discovery mechanisms, such as service registries, help services locate each other efficiently, even as the system scales. Load balancers distribute incoming traffic across multiple instances of a service, ensuring even distribution of workload. This ensures that no single instance is overloaded and helps maintain application performance, reliability, and availability. Microservices often have their own dedicated databases or data stores tailored to their specific needs. This promotes data isolation and allows services to evolve their data models independently, reducing the risk of data conflicts. Monitoring tools collect metrics and logs from microservices, providing insights into system health, performance, and potential issues, enabling proactive maintenance. These components work together to create a robust and scalable microservice architecture, capable of handling complex and evolving business requirements. APIs enable communication, service discovery facilitates dynamic service location, and load balancers manage traffic efficiently. Load balancers distribute traffic, data management ensures data consistency, and monitoring provides insights into system health. Together, these elements form a cohesive and resilient system, ensuring that the microservice architecture remains efficient and effective.
Please like and subscribe to my YouTube channel, and press the bell icon to get the latest updates on technology.